you start asking.
Calling to say I calling to say I
Alright, what's going on, guys? Coming back again for another learning session. Let's see if I can throw this. There we go. That might be better. Okay. Alright. So last time we did the basic, what was it? Basic algorithm scripting. So we did that not too long ago. And now we're starting up on Object Oriented Programming, which we've already been working with objects, but I think this is going to go just more in depth and we learn about prototypes and yeah, just different just different things to go with the objects that are more in depth than functional programming. And then after that, we'll be doing intermediate algorithm scripting, which will be a lot more complicated than what we've been doing, but it's okay. We'll come to that when we get to it. Definitely will be a little nervous trying to go through all these. It's gonna be a lot more complicated. So yeah, I know I'm a bit earlier today. Remember, it's Friday, so sometimes I usually start off a bit early. But yeah. So we'll try getting into this here soon. Hope you guys have had a pretty good week. I would have done this a lot. I would have done this way sooner, but I had some hard times at work. Like, just a lot of things going on. So had to address all that. So yeah, I don't know if we're really gonna get all the people that we wanted today, but we'll just have to see what comes up. But yeah, I see there's a few people here already. Alright, I mean, I might as well just go ahead. I mean, it's just been a really busy week. So let's get it. Let's go on it. Let's get through here. Alright, so I'm gonna switch this over. Alright. So starting off on the object-oriented programming, we have functional next, which there's 24. We have the intermediate algorithm scripting, and then we finally have our projects, which we have to make five projects. So yeah, all these things are, just like, all the things that we've been learning, but we'll have to put all of our stuff to the test to do that. But thankfully, we got a little bit more time before that. So let's jump into the algorithm, object-oriented programming. If you guys have your coffee, go ahead and get it. Take a few drinks of it, and let's see what. Let's get through here. So, as you can see, you guys already know. You have to define, your object with a let or a const variable. You have the name of your variable or your object, and then you make it equal to, and then you have obviously the curly braces and your semicolon, and then all the properties are in here, right? So it wants us to put our name, right? The name of the dog, which would be, okay, so doggo. Alright, and then we put a comma because we're gonna make another value. And then num legs, right? And this is gonna have 4, right? Now, as you know, we can have a bunch of different values in here. We can have, arrays. We can have, objects within objects. And, those would be called nested objects. And, I mean, it's pretty self-explanatory. We've had to do these in a few, in the past. But yeah, there you go. This is defining our new object. Throw it next. Alright, so we created the object. Now we have to use dot notation to access the values inside the object. Remember, we have the bracket notation, we have the dot notation. Well, this is how we get in here. So we will print both properties of the dog object to your console. So console.log, and we will do so dog.name, and that's going to print out the name for us where it changed it to spot, and we have the console.log where we have the dog.num legs. See, there's 4. That's how you access them. You guys should have a pretty good handle on that already. Now, I'm not sure if we went over this. I think we did, but just to make sure, you can actually make functions inside your objects that pertain to your object. So these are what we call methods. You have functions that are outside of your objects, and we call them functions. But whenever they're inside here, a lot of the time we refer to them as methods. So methods are properties that are functions. This adds different behavior to an object. Here's the duck example with the method. So see, as you can see right here, this is your property name, right? How it says say name, but this will actually be the name of your function. Like, so that's why when we call it down here, it'll say duck because that's the object, and then dot notation, and then you have the say name right here. But you have to put this right here, your parentheses, because with any function you have your parentheses, and if it takes parameters or arguments or anything, you put it inside here. So using a dog object to get a method called sayLegs, the method should return the sentence, this dog has 4 legs. Alright, so how we do that, remember, it wants to say legs, right? And then there's your, okay, so that's the name of our function, and then we have to declare it, that's a function, right? Alright, and then in here, we could do our function like this, or if it's pretty short, we can do it like this. Oh yeah, we don't have to use that. Okay. So in here we will have to return, because we have to bring it back. We have to return something if we're calling it. I mean, you really, I guess, don't have to, but in here we're going to. But so we want to say this dog. Now we can do this, but if you remember, we have the string literals that we could do. So we could do this, right? But remember, if we actually put those backticks, like up at the top, like top left of your keyboard, you have those backticks. You can actually say the dog has. Now, this is where the difference comes in, remember? Because you have the duck name, right? Like how we did in this example, you have your concatenating the string by adding the plus, the name, and then adding another plus, and then doing this. Well, if you remember, to make that a lot easier, we don't have to do that. We could just do the dog has, and then remember we do the $, and then we would put the curly braces, and then we're gonna call the dog's legs. So dog.legs, right? And then the dog has 4, and then we go legs. See? Done. Easy. And then we end that because that's the end of the function, right? And then when this prints, it should say it. So to show that, to make sure that it's doing what we do our console.log to show what it's doing. And the dog has undefined legs. Oh, and that's because we didn't do it exactly the way it was supposed to. Like, we didn't just put legs in here. It's num legs. So we have to do num and then legs. See? Now it actually shows the 4. See? So you gotta make sure that this is exactly correct. So the dog has num legs. And so we call that function here for say legs, and then it prints us back these 4 legs. Well, it doesn't like the fact that I'm calling it, so when it's done, just remove it. To return the given string, note that punctuation and spaces matter. Alright. To return the given string, note that okay, so where this this, because it's looking directly for that sentence when it's doing a comparison. Okay, there we go. Right. Okay. So right. Okay. So now we're doing something a little different in here. So we've been calling itself whenever we've been doing this, right? Like, we would just put, whenever we're putting it in here, we have dog.numLegs, yada yada, right? Well, there's a better way of doing this. If you're actually referring to this object, right? Or, you know, yeah, this object, you don't have to actually put dog, you know, .numLegs. So we'll go over this. A way to avoid the issues, while evaluating access the object property, there is a pitfall here. If the variable name changes, any reference the original name would need to be updated as well. So yeah, anything you do right here, if this changes, then this is no longer valid, and it's gonna bring issues. So to avoid stuff like that, a way to avoid these issues is with this keyword. So if you can see where we had up here in the example where it had dot name, we're actually changing it to this dot name. So that way it would always say that this function or this object name, we're going to get the name of this object at all times. So you're not explicitly having to call it. You can actually modify it and get what you need to. This is a deep topic, and the above example is only one way to use it. There is tons and tons and tons of different ways to use the keyword this. It just essentially means that you are referring to when you're calling it within a function, or, you know, I guess a variable, whichever, you know, anything that you're calling it within, it's going to, in that scope, it's going to refer to it. It's referring to whatever is the parent of that scope. It's going to give those properties, which is why we're going to change the dog.numLegs, right, to this. So there you go. So it's going to say this.numLegs. So this, no matter what we change it to, it's always going to put whatever we call it as. So as you see the dog.sayLegs. So this is still going to be dog because we're still accessing this right here. But the method that's inside of it will always refer to this name. Right? So even though when we call it, this is always going to be different based on what object we're calling. But the inside of it right here is always going to refer to whatever its parent is. So it's going to say whatever this parent is, we're going to get the number of legs. So there you go. So we could do a check, but I think we already know it's going to. So there we go. So remember the keyword this, because this is going to come in handy a lot. So so here's a new thing that we have to do. And a big thing in objects that we create, and it is called constructors. So constructors are functions that create new objects, right? So when we create like new objects, instead of explicitly defining one, right? Like right here, like if you just say this bird is automatically going to be this, this bird is going to, have this color, number of legs, right? Like you have that. Well, if you want to make multiple birds and multiple different things, you could actually, be able to create a constructor to be able to do that, where you can make your own individual birds and objects throughout your code. So remember that, because constructors are a really big part of JavaScript. So this constructor right here defines a bird object with properties name, color, and num legs, set to Albert, Blue, and 2 respectively. So constructors follow a few conventions. Constructors are defined with a capitalized name to distinguish them from other functions that are not constructors. Okay. Constructors use the keyword this to set properties of the object they will create. So if you see this right here, this.name, this.color, this.numLegs, it's basically saying when we create this, is basically saying no matter what this is that we're creating, we are setting these values to that, right? So constructors use the keyword this to set properties of the object they will create inside the constructor. This refers to the new object it will create. Right. Constructors define properties and behaviors instead of returning values as other functions might. So create a constructor dog. Okay. With properties name, color, and num legs that are set to a string, and at numbers respectively. So we're going to create a constructor. So if you notice here as well how it says function, right? It doesn't have an actual keyword of it doesn't have data types. It doesn't have let or const or var. It has function, and you're basically making the function bird, but you're calling it actually as an object. That's why you have this.name, this.color, this.numLegs. So this itself is like an object that you can create over and over and over again. So how we do that is we're going to do function. So we have function dog, right? And now we make the dog function, but it's actually going to be an object. So we do the this.name. This is going to equal. Okay, so doggo. It's going to change it. So doggo. This.name. Oh, in here we have to actually. Put lines, because this is a function, so we actually have to put lines. It's not taking it as an actual object. This is just to make an object. So we'll do doggo. Oh, this dot. We need color. So let's go with brown. Okay. And then this dot num legs, and then we're gonna go with 4. Okay, there we go. So here we go. We've created one. Dog should have a name property set to a string. Oh, that's right. Remember, because so we are making an actual constructor, we have to actually put a capital. We have to make sure it's capitalized. So, gotta remember that as well. Okay. So there we go. We have now created our constructor to make these objects. I love coffee. All right. Let's see what we have. All right. So now we have to create one. So inside the constructor always refers to the object being created, right? So this is just a default, right? So if there's nothing put in here, right? I guess if we just call dog, like if we just did, you know, console.log dog, right? So probably some undefined setting name. So if we did, I guess we can't really we can't just create dog. Well, I guess if we just create a new dog, okay, that's why. Okay. So, use the dog constructor from the line to create a new instance of dog, assigning a variable hound. Okay, so let hound is going to be the variable name equals new dog, right? So we have the new dog, right? That's the new object. So this right here is the syntax to create an actual new object. Is you have the variable, the data type, you have the hound as the variable name, and then you're equaling to a new dog constructor. Now, here's the thing: if you don't put anything inside there, then this is what it's going to be. It's going to be, you know, hound.name, right? And if we do a console.log, right, the hound.name, so it automatically gets the default name of Rupert, right? But what if we want to create our own one with its own variables and that sort of stuff, right? So we go in order. So the first one is this.name, right? We have the this.color and this.number legs. So we could put the name as new dog, color as black, right? And then we have the number of legs. Well, let's say it was a little disabled, so we're gonna have 3. So let's look at this. So now our new hound object, if we do the console.log, so we've essentially created a whole new dog. And then if we did hound.name,
silence awaits you in a bitter heart of darkness. You're lost again.
oh, okay, that's why. Because, okay, that's for a later lesson. We'll talk about that here soon. Because you would be defining arguments. So if we're putting arguments in here that aren't even defined in there, and it's just going to say, I don't know what you're doing. So, okay, I'm getting ahead of myself. That's my fault. We're creating a new one right here, right? New dog. Create a new instance of dog assigned to a variable hound. Okay, so let's just put hound, right? We already created that. Now, we could do this. We could get the default hound, right? And where it was saying in here, where you can just call the name and then change it to whatever you want. So you can change all the default names in here. So you can do hound.name. We're going to change it to Rupert. We can change it to Doug, right? So we're going to change that name. And then we can do console.log hound.name, right? Now it's Doug. It actually changes everything inside here. So if we want to, you know, you can have this object, this hound right here, have all these default names and stuff, right? And you can just do it this way. Now, I know it's going to talk about it, so we'll just wait to where we assign our own parameters and, you know, take arguments in. But we'll just do this for right now because I don't want to get way too ahead of myself. So here we go. All right. Oof. So now we're actually going to be writing. We're going to actually be writing actual parameters that we're going to be going in, and this is what it's asking for. So remember this dot name, you know, that's going to refer to the dog. You also you know, this dot color, right? And then you have this dot num legs, right? All right, so you have these, right? And this is all going to refer to this, like to this constructor we're building. Now, we already know how we can just, you know, assign each one of these, right, its own values inside here. Now, if we're sitting here and we're like, okay, well, I want to be able to create my own objects, and, you know, I want to create my own unique. I want to create a new dog. Like, I want to create an object with dog or whatnot, but I don't want to use this as default parameters. I want to make my own, you know, my own type of dog. So how do we do this? So in here, remember, with any function, you can actually accept arguments. So this time, we're going to put name and color. But we don't want to change the number of legs. We want the number of legs to always be consistent, right? So we're gonna, or at least keep it, you know, the default at 4. Like, we don't want them to change the number of legs on here for our object. So we're just gonna keep these, right? So now, how do we get them to be assigned to this dog? Well, that's easy. So we're gonna do the assignment like this dot name. So whenever, you know, we'll take whatever this is, the new object that we're creating, right? This dot name, and we're actually going to give it the name of the argument we're taking in, right? So we do that in color. So there you go. See? Now you have this dot name, you have this dot color being the color, and then the number of legs is default to 4. Now, it wants us to create name the new object called a terrier, right? So let's do this. So now we want to create a terrier, and then equals new dog. Now we're finally creating our new dog because now it's accepting 2 arguments. So what do we want our names to be? Well, we'll do the dog name of, you know, we'll change it to Terry. Okay, Terry. We're gonna change the color to. We're gonna give it a color of. Let's give this one white this time. So we're gonna have a terrier that's, you know, white. So there we go. And remember, we don't have to give a third parameter because we already know that the default is always going to be 4. Like, that's what we're going to fix it to 4. Yeah, so let's see what happens. So now we're creating this new dog. When we do a console.log and we call the terrier to see what's inside, right? So now we can see that the terrier object that we created, the new dog that we created, has the name of Terry, has the color white, and it has 4 legs. So now if we just do name, right, we call it, it's going to print Terry. If we, you know, get the object and we call, you know, white, no, color. Dot color, it's going to print off white. So there you go. Now that is how we can create our new objects from constructor, like, and how you can keep creating new objects without having to, you know, always have the default. So there you go. Well, And don't get me wrong, I mean, you can still create your, own objects. If you really want to define, a default, object, and you really want them to have these properties, and you're only going to have like one object, you're not going to have like multiple objects of the same character. So you can just keep making, these objects, and you can do dot notation to change those values and that sort of stuff. But if you notice you're creating the same object all the time, hey, what's going on, Zul? Anyway, if you are creating the same object more than once, like multiple times in a row, and you're getting like kind of fed up with that, well, if with functions, we try to shorten that all the time to prevent from having to redo something over and over and over again. Well, this is how you do it. So it's like, okay, we're not going to just have one dog. We're going to have multiple dogs. We're going to have multiple, characters in the video game, or we're going to have multiple birds or whatever that we're doing. We could even say, shipments. Like, let's say like we're doing shipping and receiving items and sort of stuff and doing storage. So, all those storage items have specific characters. And if you're entering all these, you're creating all these objects and different things. And sometimes you'll put those objects inside databases. So this is the good way to access them and put those in while still being able to, alter things with those objects. Like if you select a certain line, it will call that object, and you can be able to say, okay, I want to change this field to this field, and it'll actually change that object property to whatever you're wanting to, and change it, go ahead and send that into a database. So there's a lot of reasons why you would use these the objects, these parameters, and like how you would create new objects and this sort of stuff. So that's why it's a huge essential part of JavaScript. And yeah, it's gonna only keep getting better here. So we've created finally the new dog. All right. Okay, so new bird. So what are we doing? Verify an object's constructor with instance of. Okay, so anytime a constructor function creates a new object, that object is said to be an instance of its constructor, right? Because we're making new ones, you're essentially making an instance of it. Allows you to compare an object to a constructor, returning true or false based on whether or not the object was created with the constructor. So, okay. So here, okay, so this is two different things. So if you're looking and you do the let bird, right, equals function, you got the name color, and you're doing this name, this color, this number of legs equals 2, and you make a new instance right here. So yeah, you do this right here, and it's basically the same thing as writing function bird and then putting all this in here, but you are assigning just the function into this variable instead. So it's doing the exact same thing. So don't get tripped up. Don't think, that, hey, this is weird and this is different. It's really not. It's pretty much the same thing. You're just assigning it to this variable here, instead of just, giving the function its own name. So now, if you look at here, it's saying let crow equal new bird, right? Right. So this right here is a constructor, as you already know. This is, what we've already made. Now, whenever we create our object, right, and it's a crow, and it's a new, making a new bird, this is an instance of that constructor. So when we do crow, which is the name of this, object here, is an instance of bird, right? It's going to come back true because it's like, yeah, you made that crow off that bird constructor. Now, on the flip side of that, like, look, see how you're creating this, like, let canary, and you're actually assigning it this custom, you know, object, where you have the name equals this, the color is set to this, the number of legs is set to this. Whenever you do an instance of bird, right, it's going to say false, because it's like, no, it's not. That canary is its own instance. It's not an instance of anything. So that's the difference right there. You can always check and make sure, like, okay, is this an object that was an instance of another, you know, constructor, or is this its own thing? And that way, if at any time you have to do your dot notations and all that kind of stuff, you can see that if it's not its own, you know, separate entity. So create a new instance of house constructor. So we got here function house, number of bedrooms. This number of bedrooms equals number of bedrooms, right? Calling it okay. Create a new instance of the house constructor. Okay. So let we're gonna call it my house equals new house, right? Because we're making a new object off of the house. And how many number of bedrooms we want for this house? We want, well, I would like 4 bedrooms. You know, gotta have, you know, one for you and your wife. Gotta have one, you know, gotta have one for each of my kids. And then I gotta have one for an office space. Guy can dream. So we got that, and now we want to make sure that, hey, is my house an actual instance of something? You know, is it actually an instance of a constructor? You can do my house instance of, oh, okay, oops, there we go. It's all lowercase, instance of house, right? And if we did, you know, a console.log on this, it's going to say true, because it is a new instance of, you know, it's true, it came from a constructor. So there we go. Oh, how are you guys doing so far? Just doing all right. Only 31%, but we're getting through it. Learning some good stuff.
There seems to be a sudden general explosion of mass homicide.
All right. So let's move on to the next. So let's see what this is doing. So in the following example, the bird constructor finds 2 properties, name and num legs, right? Yep, and we're making 2 new objects here with different names, right? So name and num legs are called own properties because they are defined directly on the instance object. That means that duck and canary each have its own separate copy of these properties. In fact, every instance of bird will have its own copy. Yeah, I mean, that's a given. It's not going to be the original. You know, you're making essential copies of these. So, following code adds all the... In fact, every instance of bird will have its own... Yeah, the following code adds all the own properties of duck to the array. Okay, yeah, because you're taking everything and you're pushing it. So for let property and duck, if duck dot has on property and then property, you're pushing it into there. So name num legs, right? Add the own properties of canary to the array own props. Easy. So So we want to take all right here, the object that we created, canary, and we want to put it into this array. Sure. So for, so let prop in canary, right? So here we go. So now we're getting all the properties within canary, right? So if prop dot has own property, right? Dot yeah, has own property prop, because this is the check if it has the property. If so, we're gonna do a what is it, prop?
Seems to be a sudden general explosion of mass homicide.
Yeah, own props dot push. We're gonna add it, and then we're gonna add the prop because we're gonna put the property inside. Now once that's done, right, let's get the console.log and see how our own property array is doing. So own props. Props that push. Alright, so let's see why that is not in here. Odd. Oh, wait. We want to call the okay. You don't want to choose the prop because you want to choose the object that it's going to access, because it wants canary going into, you know, have to see that if it has a prop inside canary, not the prop. Of course it's not going to do that. So console.log own props. There you go. See? Now we're putting all those properties inside there. Now, if we want to do an accessor to each one, like to see what's inside of it, you could do, you can get the values for it by canary prop. Gosh darn it. See, if you do that, see right here, you call in the canary and then it's going through each one of the properties. But remember how we do bracket notation? Like, it gets the value of each one of these. So the first value of name would be Tweety, and then you have 2 right here. But yeah, you want to push the prop to it. All right. So since number legs will probably have the same value for all instances of bird, you essentially have a duplicated variable numLegs inside each bird instance, right? This may not be an issue when there are 2 instances, but imagine if there are millions of instances. That would be a lot of duplicated variables. A better way is to use prototype a bird. Properties in the prototype are shared among all instances of bird. Here's how to add numLegs to the bird prototype. Okay. So since all instances automatically have the properties on the prototype, think of a prototype as a recipe for creating objects. Okay. Note that the prototype for Doug and Canary is part of the bird constructor, right? As bird.prototype. Nearly every object in JavaScript has a prototype property, which is part of the constructor function that created. Okay, so add a numLegs. Okay, so here we go. So basically you're saying, okay, you have this, right? And you don't want to keep duplicating every single one of those. So in order to get around that, you would just do dog dot prototype. So, prototype dot name our num legs, right? And we're going to equal this to 4, right? So it's basically saying like, hey, we're adding this value to this for anything that is attached to dog. So there we go. So now if we do a console.log, right, and we call beagle, right, dot num legs, it's going to default to 4. See? So basically it's just saying, okay, this is going to have this, this is going to have this, this is going to have this on every instance we create, no matter what it is. So, but these right here will be, you know, customized. So, we're going to make all these customized. We're just going to set, you know, all of these to whichever. And then you can set right here whatever you want. So, there we go. So that is prototype. It's just making sure that all the properties are going to be shared through all instances of whatever object you're creating. So, Alright, let's go to the next. Okay, so you have now seen two kinds of properties: own properties and prototype properties. Yep. So own properties are defined directly on the object instance itself, and prototype properties are defined on the prototype. Right? So here's how you add Duck's own properties to the array and prototype properties to the array. Right? Okay. So yeah, I mean, you can do that. You're just taking all the properties and then you're just taking all these prototype props and you're pushing it to another array. This is pretty self-explanatory. Like, we already know that we already created, you know, a prototype of dog and we add legs 4 to it, right? And this is essentially its prototype. So this right here, its own properties, like the this.name, its own properties in here is going to just be the name. But the prototype, right, is going to add the legs. So whenever you do that, it's just going to have number of legs. So it's going to have this, and then it's going to add whatever is in here. But it's not going to combine them in this. Alright. So have all the own prototypes to be equal to the array own props. So let's do a 4. Let prop in, so own, no, beagle. So we're going to do beagle, right? So it's going to show all the prototypes that are currently within here, right? So if prop dot, no, we're going to do beagle dot has own property, a prop, it's going to do a own props dot push, and then we're going to push the prop to that. Right? Now, we do an else, right? And whatever else is left, so everything's in beagle right now. It's just basically separating them out. We're going to do a proto. So, oh, no. We're going to do, yeah, that's right. Prototype props. Okay, dot push prop. Right? So now we would do a console.log to check it out. Own props has name, right? But now we have a console.log oh my gosh. So type props. Nope. It's not an accessor. There you go. Num legs. So even though they're all combined in this, right, in Beagle, it knows to basically put to, you know, what is the prototype and what is actually on its own properties. So remember, whenever you're looking that has own property, anything that you've developed as like a prototype, it's not gonna show. Unless, you see, you can just do, I mean, you could separate them out like this way, but if you just do like, you know, a push like this right here, right? And you just say, hey, I want to push this all onto own props, it's going to push all of those on there. So just know if you need to separate them out, you can do it that way. If you need to add them all into one, you can do it that way here, right? But we're going to separate out. Let's change that back. Oh, we need to have the if statement back. Get rid of our console. All right, so there we go. 42. On to the next challenge. So there is a special constructor property located on the object instance duck in Beagle that were created in the previous challenges. So duck.constructor is strictly equal to bird. Beagle.constructor is strictly equal to dog. Both would display true because they are instances of those. Note that the constructor property is a reference to the constructor function that created the instance, right? The advantage of the constructor property is that it's possible to check for this property to find out what kind of object it is. Here's an example of how this could be used. So if candidate.constructor is equal to bird, return true, if else return false. So you can, so whenever you join function join bird fraternity candidate, since the constructor property can be overwritten, which will be covered in the next two challenges, it's generally better to use the instance of method to check the type of an object. Write a join. Okay, so we're going to do a constructor that if the candidate is strictly equal to dog, right? Then, right, return true, else return false. There you go. So, okay, so what else does it want to do? Return true if the candidate is a dog, otherwise return false. So we would want to know that this actually came from a dog, right? That this is a derivative from the dog. If it's, oh, wait, the constructor. Yep. This is a good validating like function. So it's saying, okay, we want to make sure that everything in here that's getting added is from the dog constructor. It's not coming from any other constructors that we're using, like a human or a cat or whatever. It's, you know, coming straight from there. Right. So it's good validation. But it's better to use the instance of, because apparently the constructor property can be changed. Alright, so up until now you've added properties to the prototype individually, right? This becomes tedious after more than a few properties, right? Prototype.numLegs, prototype.eat equals function, nom, prototype.describe. So basically, if you keep adding these, you know, you're wanting to add these functions in there. So a more efficient way to use the set prototype to a new object that already contains the properties. This way the properties are added all at once. Okay. So you have the numLegs too, the eat function, and then the describe function here. Okay, so basically you're just adding that all these properties are going to have these set things. And now, but the constructor itself, we want all of these to be changed variable, like changed properties. So this up here, as we look, all of these up here will be changed, you know. That's why we have the this.name equals name. But we want things that we want every single one of these objects to have. And we don't have to keep defining it or, you know, have duplicates. So we want two methods. Add the numLegs property, so numLegs, right? So so you have the numLegs function, right? Nope. numLeg. No, we don't. Oh no. We're not doing it on this one. So numLegs is 4. We're gonna make the eat function, and we're turning it into a function. So, all right. So we want to return. What do we want? Saying the prototype. So console.log. So we want to print this out to the log saying, "Yay, I am eating." Right? So, well, within that function, we also have to remember we have to close that off to make sure we're ending that line. Okay, so that's one. Oh, but we're going to another one, so we have to put a, you know, comma after that to indicate that that's not the last one property. So now we have a describe function, right? But now I look at this and it's like, all right, I get it. But why do I have to keep putting function for everything? So we technically could just do this, right? And just do a pointer function, right? I mean, technically, you could do that. And just, you know, just say this and just put all your, you know, all your variables inside here. So you can do it this way, which is what I'm going to kind of do here, instead of writing function each, but it wants you to get used to writing that syntax. But I think we're more well developed right now that we can just do this, right? So let's do console.log. Oh. Okay. So we want to make the name, right? Oh. I hit a button and it decided to do that. Console.log. Alright, so remember, now we're going to use the ticks, right? The backticks, because we're going to be using a variable in here, right? So, describe, so my name is, and then we put in the $sign, and we have what's in here, so this dot name. So now we're calling the name, right, of this of whatever object you're making, right? So now if we ended up coming, you know, and doing this, right, where we make a new object, so let hound equal dog, right? And then the only thing we have to do is give it a name. So the name of it will be doggo again. Doggle. I like that. So let's do that. So we're gonna get this. Right. So how? Oh, we have to do new to create a new instance, right? And now we will do on console.log, and then we want this hound dot. So now call the eat function. See? Undefined. So there. Oh, because we're already calling it. Yeah, it already prints it off to the console. Say, look, see, now when I do a hound and .eat, it automatically throws it out to the console because of all these prototypes. So it's adding it to this prototype. So you have this, which only has one in it, but you have all these extras that are being added to every instance of it. So that way we're not having to, you know, have a bunch of duplicates. Okay. So there you go. So that is how we do this. All right, we are at 50%, so I'm going to pause it real quick. I'm gonna use the bathroom and then we'll come back. So, see you here in a second. All right, we are back. So we had hit the halfway point. Gotta push forward a bit more. I know it's a lot of material to kind of go over, but it's definitely a lot of essential pieces of the, of this. And, in later challenges, we'll definitely probably have to use it. So, let's see if we can get through this. And then, yeah, I'll just wind it off here, and then we'll do functional programming next, after. Yeah. So yeah, let's finish this off. Okay, so all these, define the constructor property on the dog prototype. Okay. So you can indirectly, well, you can assign it for, if it's true of bird, if it's true of object, and then you have an instance of bird. In order, these expressions would evaluate to false, true, and true. Okay. There's one crucial side effect of manually selecting the prototype to a new object. It erases the constructor property. Okay. This property can be used to check which constructor function created the instance, but since the property has been overwritten, it now gives false results. So, if you have a duck right here, and a constructor is a bird, it's gonna say false because it's I guess not. But it is an object, so it's gonna say true. And the duck is an instance of the bird constructor. So yeah, that's a good thing to know. But to fix this, whenever a prototype is manually set to a new object, remember to define the constructor property. So we want to make sure that, whenever it is called, we want to make sure that the constructor is set to dog. Oh, there you go. So there we go. To fix one is manually set to a new object. Remember define the constructor property. Okay, so define the constructor property on the dog prototype. Okay, we already did. So now anything that's made of it, the prototype assigns the constructor a dog. So remember, these are all set values. We're setting that to here. These are all dynamic values we're adding to here. They're not fixed. So we're altering the properties. Okay. Just like people inherit genes from their parents, an object inherits its properties directly from the constructor function that created it, right? So for example, here the bird constructor creates the duck object. Well, right, because it's inheriting everything from here, right? So duck inherits a prototype from the bird constructor function. Okay, you can show this relationship with is prototype of method. This will return true. So bird prototype is prototype of duck will return true. Okay. So basically it's saying that it's taking this, the bird constructor and prototype, and then it's saying, duck is a prototype of, the bird function. So it's basically saying, yeah, it's true, because it's using prototypes. Or the new prototype that you're creating is a prototype of. This would be, yeah, it's using that to check the prototype of Beagle. So you want to see that the prototype here, that's adding those, that the duck is using prototypes based off of bird. So it would just be like Beagle dot prototype dot is prototype of, and then Oh, no. You wouldn't put beagle. You put dog. Right. Right. Dog prototype is prototype of, and then put beagle. There you go. And that would result to true, because if you're making a dog prototype, right, the prototype is going to be based off of the dog. Or the beagle class, or the beagle variable is going to be a derivative, or it's going to inherit all the prototypes of dog. So there you go. Basically, it's just confirming that when you make a prototype, it's going to come based off of that dog. Okay. So the type of, remember that when we used type of, it gave what this was, whatever the type of like value it is. All objects in JavaScript, with few exceptions, have a prototype. Also, an object's prototype itself is an object, right? Because so if you did prototype bird.prototype, it'll just say it's an object, right? Prototype can have its own prototype. In this case, the prototype of bird.prototype is object.prototype. Right. Okay, so right. So you have your object dot prototype is prototype of bird.prototype. So that would be true because it is based off an object. How is this useful? You may recall the hasOwnProperty method from a previous challenge, right? Whenever we did the hasOwnProperty name, you know, it would result to true because it does have name. But if you use anything else, it's not going to report true. It's going to say false. That's because it's a prototype. That's where all those fixed parameters or properties, all those fixed properties that we made within the prototype, even though they're getting added to that object, it's not going to show as having its own prototype or its own property. The hasOwnProperty method is defined in object.prototype, which can be accessed by bird.prototype, which can then be accessed by duck. This is an example of the prototype chain. In this prototype chain, bird is the super type for duck. Okay. While duck is the subtype. So, okay, bird is the super, or the parent, and then duck is the inheritor of bird, which would make it a subtype. Object is a super type for both bird and duck. Right. So you have duck, which is the lower, then you go to a higher one, which would be bird, and then the highest one off of that would be object. So object is a super type for all objects in JavaScript. Therefore, any object can use the hasOwnProperty method. So this would be, okay, so we got to define this chain. So object, right, because this is the biggest thing you can get, dot prototype, and then dot is prototype of dog.prototype. Holy crap. So this right here, so if you're going like this, right, it's saying that this dog.prototype is a prototype of, you know, beagle. So beagle is a prototype of dog, right? So this would be true, and now you're going higher than that. So you're taking the dog.prototype, which is right here, and you're saying is a prototype of object, which, yeah, would result with true. So basically this is going to come out to true that yes, it's it's an object derivative of object. So let's go over how this would be useful. You may recall the has-on property method from the previous challenge, right? Is defined an object prototype which can be accessed by bird prototype, which can then be accessed by duck. This is an example of the prototype chain. Bird is a supertype for duck. Yep. Duck is the subtype. So an object would be the supertype for duck and bird, or bird and duck, but bird would be then be the subtype because of this. If just depending on how high you're going. Object is a supertype, and all objects in JavaScript, therefore any object can use the has-own property method. Holy crap. So if we do the has-own property, right? Like, remember how we did the has-own property to make sure in here? Well, this would be like the equivalent of saying well, would be is property of. So all Beagle yeah, that would be true, right? I understand that. Right? Because it's a property of. I'd like to see like how this is actually used, like syntax wise, because I can see how it's a bit confusing, like in practice. Okay, there's a principle in programming called don't repeat yourself, DRY. The reason repeated code is a problem is because any change requires fixing code in multiple places. Right. So you could fix it in one place and not have to go through tons and tons of code to replace it in other areas. It means more work for programmers and more room for errors, right? Notice in the example below that describe method is shared by bird and dog. So you can see describe function, right, is the same as this one right here. So we're technically repeating ourselves here. So yeah. So instead of having to say the same thing in each one of these, it would be better just to, create a function where you can just stick it inside here and then it'd be fine. So the describe method is repeating in two places. The code can be edited to follow the dry principle by creating a supertype or parent called animal. Okay. So we have the function animal. So all animals are going to use the describe method. So function animal, so we're creating the animal, and then we're going to do an animal.prototype, right? So we're taking the animal, and then we're going to add these default things inside of it. So constructor will be animal. So this is basically, so the function, okay, so I have to look. So there's a function called animal. It is empty right now. So this is an empty function called animal, or empty constructor. And so you're making an animal.prototype, you're giving the constructor a name of animal, and then you're giving the describe function this right here. So since animal includes the describe method, you can remove it from bird and dog, right? So now you have to just constructor bird, and you can have a constructor of dog. The eat method is repeated in both cat and bear, right? So edit the code in the spirit of DRY by moving the eat method to the animal super type. Okay, I see what's happening, and this is what we were talking about in the previous one. It's just, you know, it was kind of difficult to kind of understand, but see, you have this function cat right here, and then you have this prototype, right? Well, now you also have this prototype here from bear. So you have two objects right here that are created, right? You have the cat and the bear object constructors being created. Then this cat right here has two properties called eat and constructor, but then you have this bear that also has a prototype of eat and constructor. So as you can see, the constructor changed. This one is cat and this one's bear, obviously, but this eat function, as you can see, are both the exact same. So how do we make these prototypes both have this in there? And that's what it's saying. So we're going to take the eat method out of here, take this out, and then we're going to just add it into this animal prototype super type, right? So now whenever we do the animal, right, we're going to assign it to bear and cat. So we don't have to include it in there anymore. We now have it within animal. So I'm sure in the next one it's going to tell us how we can add those to these prototypes. Okay. So let's look. In the previous challenge, we created the super type, right? So this and the new challenge will cover how to reuse the methods of animal inside bird and dog without defining them again. It uses a technique called inheritance. The challenge covers the first step, making an inheritance of a super type or parent. You already know one way to create an instance of animal using the new operator, animal equals new animal, and then you don't have anything in there because there's no in this constructor there's no it doesn't have any arguments it's accepting, right? So you have, you know, your animal.new animal creates one, but there are also some disadvantages when using the syntax for inheritance, which are too complex for the scope of this challenge. So instead, here's an alternative approach without those disadvantages. So let animal equal object dot create animal dot prototype. Okay. Okay. Object.create object creates a new object and sets object as the new object's prototype. Okay. So if you're making a super constructor, like for, let's say you have like smaller, like you have other objects that are going to be part of a super object, then you would make that super object a object.create, and then you would put your oh man, okay. Yeah, you would put your object in here that you're using on the next lower level, and you do that prototype. But so it's saying that every single one should not use the syntax for inheritance. So to use this would be better. So creates a new object and sets object as a new object's prototype. Recall that the prototype is like a recipe for creating an object. By saying the prototype of animal to be prototype of By saying the prototype of the lowercase animal, right? Is what we are, you know, variable to be the prototype of okay, the function animal.prototype. Animal. You are effectively giving the animal instance the same recipe as any other instance of animal. Right. Oh man. That's a lot of different things. So recipe as any other instance of animal. Okay, so animal.eat would of course be nom nom nom. So okay, so we're gonna just change this duck, right, and make it a new instance of animal, right? So would be object dot create, and then it'd be animal. Oh my gosh, fat fingering. Animal dot prototype. There we go. So it's making the prototype and giving everything within the prototype to this duck. Okay, so within the animal, it's still giving all the prototypes and so it's giving the prototypes and all the own properties of animal. But this one, it looks like it's giving only the prototypes. So, man. Okay. So that to get the prototypes of everything to have this, you know, like if you have like a cell phone, right, and you have like all these things, how would I do this? So a cell phone and a computer would both share a processor property, but it wouldn't be the same. Okay, I guess this is the best way to define it because all animals eat, and some of them would, you know, we want to print the same thing for all that, so that would make sense. Okay, so bad example. So I guess this is the best example you can get. So you want pretty much all the prototypes from here to be created from here for the duck and beagle property, or duck and beagle variables. So object dot create, so animal dot prototype. Okay. Then, okay, so if I were to do, alright, so if I were to do duck dot eat, right? So essentially we're just doing this, so each one of these gets all the prototype, right? All of these things. Oh my god. And then if we call a duck console.log, if we also do a duck is an instance of animal, it would come out as true, because it's true, because these are instances of it. Yeah. Head hurts, but if you were using these for obviously multiple animals, like different things, like in general, that are always the same, we would have to do it this way to make sure that all of the instances are getting those same outputs. But then it makes me think, like, yeah, you can have those, but what if you're doing, so what if, okay, so this, hear me out. Now we need to make a function. Now let's just do this. Can we actually just make a dog? Let's make a dog with, I just want to see how this would, no, it's not gonna work. I don't know how you would use that with already created objects to add that on there. I'm sure it will show us. So let's see. So, oh, okay, so that's how you do it. So you wouldn't have to add anything actually to these. Because, all right, oh my gosh. So, if you know all these animals are going to have this, right? This is why we had that hierarchy of things, going up higher. So this bird, like, we take each one of these objects, like the prototype, right? And then we make those equal to the animal prototype. So that way it inherits all of those properties, right? And then that way, when we create our new duck, right, that's based off of the bird prototype, like the bird object, right? Because the bird object is going to have, a thing of name, and we're going to name it Donald. But then if you use the duck.eat, even though the eat method is not inside the bird, it is higher than that. It goes in the animal. So that way, anything that you make of this bird or like a bear or anything like that will always have that eat method inside there to print out what you want it to. It'll have those properties. Oh my god, dude. That was mental gymnastics trying to figure that out. But you have to see the big picture of how all these things work. So we did it. All right. So let's do this. So we got this. So modify the code so that the instance of dog inherit from animal. So we need the dog. So dog, right, dot prototype is going to be equal to the object, right, dot create, and then object dot create, and then animal dot prototype, right? So we made the animal prototype, which is the highest thing that this can be. We made the function right here that's empty, and then we gave it a prototype of this, and then we made it this right here, right? So now we create the beagle, right, as a new dog. Then we could do the beagle dot eat, and that will print out nom nom nom, because so this is how it goes, right? Beagle is the lowest, and then you go higher, which becomes the dog, and then you go higher than that, which is animal. So lowest, so this is subtype, supertype, and then this is the supertype of this and this. Now remember this, because we're like, this right here is gonna come like whenever you're making classes. Like, you know, you're trying to import classes from other, you know, other files, like import, you know, objects from other files. There's going to be ones where you're going to inherit those properties, and then you're going to create your own, you know, things based off of that. So this is kind of what it means to like inherit those properties, like extend, you know, a class into new, you know, other classes, and inherit all those properties. So we would probably put like this or something in its own class, and then you could probably even create a new class that's for like dog or something, and then extend the dog class to animal, and then get all of those, you know, those properties from animal. It's a lot. And this is what object-oriented programming is just a lot of, you know, accessing objects, manipulating them, you know, inheriting from them. Like, it's basically taking all these things, and instead of having to rewrite them all the time, is being able to, you know, create your own things from it, and you know, set out functions and methods to be able to prevent having to, you know, write like customized code all the time. But it's definitely a mind-bending thing until you actually start looking at how it all works together, and then you're like, oh, I see it now, because you're working technically right here from, you can see it from the bottom up, but you need to work from the top down, so that you have to like get a visual like kind of thing, like, okay, when you've written out all your code and you're like, okay, what can I do to make this more efficient? Well, this is what it would do, is like, okay, what things are using the exact same things? How can we make this better and more usable? Well, if things are using the exact same functions for everything, and, you know, this is what you would do. You would just create, you know, a super, you know, a super of these, and super type of these, and then you would, you know, then assign those properties to there. So can I actually, so how would I add those to here? Like if I were to do like a dog dot prototype, and then, you know, do this, right? And add like a scratch back function, right? Now pointer, when we want to call scratch back to all dog prototypes, and then console.log, I am scratching my back, right? So this is what the prototype is equal to right now. Now how do we add these prototype to inherit into this prototype, you know? Like how do we make it a pro? Will we just do this? We can't just do a plus equal. So will we do this, where we just add this in there? Oh, we'll have to, because I doubt like that's gonna show, like if we do a beagle dot scratch back, yeah, see, it's not a function because it gets overwritten by this. So now see, that's where I would want to know, how does this get added to the prototype? Because what if you have other things, you know, that you have inside here, but you want to inherit, you know, those prototypes from the animal prototype. So how would you do that first? And then? No, because then that's overwriting this. So how would you... So could you add dot prototype and then make another one that says animal and equal that? Like, just create a new property on the prototype called animal and then equal it to here, to this. No, because then that would add it to the animal prototype and we don't want to do that. Wait, I can do this around, right? So instead of doing this, this is what I create, right? And then if I do we want to have this inherit the properties of this, right? So dot animal props. So now create that, and then we have scratch back, right? But then if we have dot eat, right? No, we'd have to do dot animal props, right? And then do the dot eat. There we go. So basically, you're creating this prototype, but then you're adding a new, all those props into another level. Like, you're assigning those properties of all of these objects, right? Of the animal prototype. You're assigning all of those inside the prototype of here. So you can create a prototype, you add it inside here to inherit from, and then you can actually get the value of those of diving down deeper. Now, unless there's a way that you can, you know, you make this prototype and you're inheriting all these, and then you'd have to do the same thing with, you know, bear and all this kind of stuff, and add the animal prototype and, you know, yada yada, keep doing that. I mean, you could do that, but you'd have to always add it as a new, you know, property of dog. Because if you go in here, look, right, if I did the console.log, right, and looked at the dog.prototype, see, it's gonna have the scratch back, right, function inside here, but then we're also adding the animal props and we're putting inside there, see, and then you have to access the animal properties to get the eat function. So that's another way I would assume that you could do that. But yeah, let's just do it the way it was intended. And then just do the prototype equals this, beagle new dog, and then beagle dot eat. There you go. So we just explored a way that we could add all those properties inside an already established prototype. So now, when an object inherits a prototype from another object, it also inherits the supertype's constructor property. So it's going to be animal, right? Like if you're doing this, getting the prototype, getting this prototype, right? There's nothing defined though. So we want the constructor. So fix the code so duck constructor and beagle constructor return the respective constructors. So in here we have the constructor that is made in here and in here, right? So in order to do that, we would do okay, so we obviously want the bird dot constructor to equal bird, right? We don't want to inherit it, and then we want the dog dot constructor to equal dog. So that way these aren't just animals each time it would construct it with bird, right? So the beagle got constructor. Oh, wait. Oops. Okay, so let's do this. We have to fix these, right? And we gotta do the duck to make sure it's bird. And make sure beagle. The beagle constructor is dog. So that way we know what types they are, that this is a bird and this is a dog. So now we can do a console.log to make sure. So duck dot constructor to make sure it's inheriting. All right, so we have to do the prototype. So we have to make sure the prototype of it is set to bird, because that's where it's at. If you put it inside here, it's going to change when you do a prototype. So we're changing the constructor there. Prototype.constructor. That should. Wait. Would I change it here? Duck.constructor uses function animal. So birds should show that they were constructed by bird and not animal. Would this be true? Then I could just do duck is instance. Well, that's gonna still say that's instance of, hold on, bird, right? That's true. But if I take this off, it's still the same thing because it's still coming off of duck. That's a bit confusing, right? So we want to make sure that okay, so we want the bird dot prototype is equal to dot structure is equal to bird, and dog is prototype dot doctor to dog. So yeah, you want to make sure these constructors. So if we do duck Okay, so it's returning a bird now. So now we do the console.log and make sure the beagle is now a constructor of dog. There you go. Okay. Jeez. Okay. A lot of work. Okay, so we got it. It's calling the right. Yeah, it's done. Next one. Constructor function that inherits its prototype object from a supertype constructor function can still have its own methods in addition to inherited methods. For example, bird is a constructor that inherits its prototype from animal, right? Because it has the nom 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 whatever. And then you're changing the constructor to bird. In addition, what is inherited from animal, you want to add behaviors that are unique to bird objects, right? So a prototype dot fly. From animal, you want to add behaviors that are unique to bird objects. Here, bird will get a fly function. Functions are also added to bird's prototype the same way as constructor functions. So now instance of bird will have both eat and fly methods. Okay. So you're starting out the objects. So you're just adding on to them. Okay. So you're setting the prototype equal to the object animal prototypes, but then you're adding its own properties onto that. So what we did was in a couple of these steps ago, we assigned that dog prototype. We had all that, and then we assigned all those animal prototypes in its own value. And you could get selectors and do that, but in this it does it the opposite way, where you're inheriting all of those properties from the supertype, which is the animal. You're getting all of those properties in there, but then you're adding the small things to each one of those objects to the property, to the constructor, to the the bird constructor or the dog constructor. So as you can see right here, we're adding the fly. We're adding a fly property to it. You could probably, for a dog, you can do bark, yada yada, do that sort of stuff. But all animals eat, so we wanted to add all those on there. So basically you're having like this big hierarchy thing right here. And you got like your most top, which is animal, and then you type type of animal, like a bird, and then you have a dog, and then you're going down further of like what species of it would be. So all right, so let's see how this goes. So for the dog, we want to make the dog dot prototype we want it to equal the object dot create, and then we will add the animal dot prototype, right? So now the dog has inherited all those right there, but now we want to add onto it. So we want to add it wants us to add bark. So what we would do is dog.prototype.bark, right? And then equal woof. So now each thing that we add, we would have to okay, hold on. So we can add that, but we want to make it a function. So equals, let's make it a function right here, a pointer function, and we will add the console.log, because we're only using bark in here, so we don't have to make like a function, that's going to be, taken everywhere or used multiple times other way. We're only going to use it inside here, so that's why we're going to use this pointer function. So we're going to name it woof, right? Okay, so there you go. And this technically doesn't have to be multiple lines. This can just be one. So we have the property.bark. So now, or prototype.bark. So now we have everything inherited from the animal. You know, everything's going to be inherited from the animal that are default. And then we're going to add our own custom things to it. So now we added bark. And now when we call dog right here, right? We should be able to add now console.log beagle.eat, right? Now, oh wait, we don't have to even do that because it already puts it out for us, so we don't even have to check it because it does a console.log for us. So eat, so we can access now that this beagle isn't accessing everything from animal, but if we call beagle.bark, right, it also says woof because it's using everything from the prototype of, you know, dog, these customized additions. So these are the properties that are getting added strictly to the dog, and then these are, you know, in the animal, right? It's adding, so see how this is empty? If you're adding only one thing, you could do the same thing, animal.prototype.eat, and then do this, you know, and then this will be instance, its own instance. We're inheriting everything from this object. So now all the prototypes are going to equal into the animal, and we're adding our own prototypes on top of that. So that's why we're getting this eat from the animal, and then we have bark from, you know, the dog objects or prototypes. So hold on, let's see what's going on here. The constructor for beagle should be set to dog. What? Okay, the structure for beagle. What? Add all necessary code to the dog object inherits from animal, and the dog's prototype constructor is set to. Okay. Oh, what? Yeah. This line above this line. So all this would inherit from dog. Right. You got animal up here and you got dogs right here. Now I'm trying to figure out what's going on. Oh. No? That should be bark. Eat bark. The bark should print woof to the console, which it does, so that beagle can both eat and bark. But it does. So what's the problem here? It should be set to dog. It is doing it's doing it. Like what's going on? Okay. The constructor for beagle should be set to dog. I mean, this pointer function, it wouldn't matter. I could just write the function and it would do it the same way. Like .bark function, and then oops. does the exact same thing. So it don't matter. It does the same thing. And the dogs set to dog. It is set to dog. Oh. Stupid. Okay, got it. Dog dot construct prototype. So we got this, right? I forgot already. Dog dot prototype dot constructor is set to dog. There we go. Gotta make sure. That doesn't make sense. Because we did this. We changed structure. Right? What if I did log eagle animal? Ugh, okay. So it is. What a crock. So nope. That hurt a little bit. Why is that? Why is that not? Dog prototype. Why is that still set to? Alright, I must be missing something. Because I did it, right? Because after this was created, I then set the constructor, assign it to dog.
Nightmare. Daydream. Stand still. Run. Scream.
With the beagle? Oh my gosh. Dot. Would that be this? That's probably why it didn't work. I did it wrong. I was wondering why that wasn't... Okay, there we go. I spelled constructor wrong, and I should have noticed that when it was in blue. Okay. There we go. Because it overwrites it with animal, needed to set it back to dog. Alright, so we'll get back to this here in a second. I need to use the restroom again. That coffee is just going right through me. Give me one moment. Alright, so let's finish this up. Previous lessons you learned that an object can inherit its behavior from another object by referencing its prototype object. You're right. The child object prototype inheriting the parent. Then the prototype receive its own methods by chaining them into its prototype. So yeah. So it's possible to overwrite an inherited method. It's done the same way by adding a method to the object, child object prototype using the same method name as the one to override. Here's an example of bird overriding eat method inherited from animal. Okay. You call ducky. This is showed else it looks like the method above. So you're overriding this, so eat right here would default be nom nom nom, and you're getting all the inherited stuff. But if you're saying, okay, I don't want it to do that, birds don't do that, they go peck. So you literally just use the prototype.eat, and then you return this right here. So we want to override the fly method for penguin, so that returns the string alas, this is a flightless bird. Right, because not all birds fly. So you got the bird being, the biggest, but then you have a penguin that's a derivative from it. And, if you got multiple penguins, you can do that. But, you don't want, you're saying the constructor now is equal to penguin, and then you can make new penguins. You're inheriting everything from here. Yeah. So let's change this out. Now we want to use the fly function, so penguin dot prototype dot fly. Now remember, we want to make this different, so we're going to make this return alas, this is a flightless bird. There we go. We also want to add in here, right? Don't have to add it after this one. We just need it right there because this is a function. So there we go. Functions don't have to get these, but I guess you can if you want, because you can see, in this right here. But if you're adding this fly to it, it does have to have an ending, because it's not its own. Because you're doing this right here, so it has to have an ending semicolon. Okay. Yep. So, as you can see below, it returns penguin.fly and console.log, and the last it's a flightless bird. So yeah, you can override it that same way. Alright, as you've seen, behavior is shared through inheritance. However, there are cases where inheritance is not the best solution. Inheritance does not work well for unrelated objects like bird and airplane. They can both fly, but a bird is not a type of airplane, and vice versa. For unrelated objects, it's better to use mix-ins. A mix-in allows other objects to use a collection of functions. So, okay, so let fly mix-in is going to equal function and an object, right? And then it's going to take that object.flies property and add the flying whoosh to it. Alright. Okay, so So now you could do a bird.fly it, and it'll actually display to the console the flying things. So if you want multiple things to have this that are unrelated, so in the animal object you'd have everything that's related and you want it to there, you know. But if you have unrelated things, but you also want them to have, you know, functions that are, you know, in the same usage, you just, you know, like they said, you would use a mix-in. And if you didn't understand it right here, we'll just go ahead and do it right here. So we have a bird and we have a boat. What both do? They glide. Okay, so create a mixin named glide mixin. So let glide mixin. Okay, and it's going to equal. Oops. Going to use an. Is that the object? Right. Well, I guess we're not using a function, so we don't have to do that. We just take the object that it's using and then add it. But what is this? Defines a method named glide. Okay. So. Oh, okay. Duh. Because we have to add the object. So we're going to inherit the object, whatever it is. So object, right? And then we add equal here, right? So what we'll do here is we'll do the object dot glide, and we're going to add the glide property to the object. And then we're going to make another method inside here, console.log. What is it going to say? Ability to glide. Okay, what would it say? Like, just, it's going to, was it going to be true or what? She used the on the Bruno to give it the glide method. So is it gonna be true? Gonna be true. Glide. No. So we're gonna make it. We're gonna make it equal to true, right? So now we can do a glide mix in, and we're gonna call the bird, and we're gonna do glide mix in. Use the boat, right, and then apply it both to them, right, and now we can use console.log bird dot glide. It's going to return true. So there we go. We have now added the bird and boat with it's going to have, if we did this, like console.log, it'll actually show the property, the new property added. So if we do bird, see, it adds it to the end of it. Name's Donald, number of legs 2, but glide is going to be set to true. Okay, it just wants a glide method. So but that's the glide method. Oh, it wants it as a method. Okay, so, okay. It wants it to actually have it as a glide method. So, we will give it a glide method. Okay, we're gonna give it to there. I can fly. I can fly. Glide. See? There we go. Now if I do a bird.glide, right? Method, it's gonna say I can glide. There we go. Okay. So in the previous chapter, bird had a public property name. It is considered public because it can access and challenge outside a bird's definition, right? So therefore, any part of your code can easily change the name of bird to any value. Think about things like passwords and bank accounts being easily changeable by any part of your code base. That could cause a lot of issues. Right? The simplest way to make this public property private is by creating a variable within the constructor function. This changes the scope of that variable to be within the constructor function versus available globally. This way, the variable can only be accessed and changed by methods also within the constructor function. Okay. So in the constructor, you have let hatched egg equal 10. This .get hatched egg count return hatched eggs. Okay. So this can get the hatched egg count, and then we can set it. It's a get hatched egg count is a privileged method because it has access to the private variable hatched egg. Right. So in here, like if you say the let, since this is not like saying name or this dot whatever is equal to this, it's actually putting its own variable. So this is isolated here, and the only way that it can get to here is by getting and setting. So privileged method, so these are getters and setters if you weren't aware. So change how wait is declared in the bird function so it's a private variable. Then create a method. Okay. So instead of this .wait, we were going to do let. So the wait is set to 15. However, we can get this by doing this. So So let's do. Alright, so we have the wait. Now the only way we can get this is this dot get wait. Get wait will equal get wait, and then okay, so there's this function, so we can get the wait, and then set. We could do the return wait. There we go. So we can get this dot wait, and then we can return it that way. Right? And then if we did a bird, I guess, dot get wait log Bird.getWeight is not a function. Oh. It is a function. However, I don't think we made an instance of it, so if we did, we can't make the instance of it. So, because it's a function, obviously, or an object. So what we do is we do a let example bird, right, equals new bird. Oh, oops. Bird. There we go. And nothing inherit, nothing, no arguments to put in. So we can do the example bird, since it's inheriting, to get the weight. Now we could do a console.log, so we can print out the weight each time it's called, and see it's 15. So yeah, you can get private variables inside here and set them. Yeah. So you have this. Can you actually do the dot weight? Can you actually do a... If you try to do the weight. Okay. So you can do it that way. Function always has access to the context in which it was created. This is called closure. Change how weight is declared in the bird function. That's a private variable, right? Get weight that returns the value weight 15. So we've done it. So let's do that. Oh wait. Shouldn't do the console. Got 15. There we go. So that's how we can call the get weight, and we can set it as well. Whew. Okay. We're near the end. We are almost there. So a common pattern in JavaScript is to execute a function as soon as it is declared. This is an anonymous function expression that executes right away and outputs chirp chirp immediately. Okay, so note that the function has no name and is not stored in a variable. The two parentheses at the end of the function expression cause it to be immediately executed or invoked. This pattern is known as immediately invoked function expression, or IIFE. Rewrite the function makeNest and remove its call, so instead it's an anonymous immediately invoked function expression. So okay, so we want this, right? And we want to make this immediately called, right? There. So as soon as, like, let's say like a page is opened or whatnot, this function would automatically just do what it's supposed to. Like, it's supposed to just automatically throw this out there. So how could we actually do this? So instead of doing this, we can actually make another double parentheses, put in an arrow, right? To this function. We don't even need this second one. See, it does the same thing. There's no arguments. It's just basically an arrow function. You're not going to call this anywhere else. You know, it's there. See? It's not going to be called anywhere else, so we're just doing an arrow function, and that's how you can do it without having to use the function. Remember, this is a, I believe, ES6 or ES... I can't remember. ES5, ES6? I can't remember which one that was introduced in. I want to say it was introduced in... I want to say it was introduced in 5. But it could have been introduced later. I mean, this has been pretty well used. But I think it's 6. Either way, there you go. That's your arrow function. So you can write it either way. Alright, 96. Alright, an immediate invoked function expresses IIFE is often used to create related functionality into a single object or module. So for example, an earlier challenge defined 2 mixins, right? We can group these mixins into a module as follows. So let motion module equal function return. So it's returning that all these function object. Okay. So you have all of these which are made, the glide, and then you got the function fly mix. So you have glide mixin, fly mixin. So for motion module, if you want to just do motion module, it takes the function, returns glide mixin function, right? Glide mixin is going to be the function. You're going to use the object function, glide in the water, and then so basically you're making an object here of its own object without really a name. It's going to have this, and it's going to have the object.fly and the object.glide. So motion module. So now you can use the motion module and combine these. So note that you have immediately invoked function expression IIFE that returns an object motion module. This return object contains all the mixin behaviors as properties of the object. The advantage of the module pattern is that all of the motion behaviors can be packed into a single object that can be used by other parts of your code. Okay. So I get it. So we have this cute mixin, and then you have the sing mixin, right? So we can have is cute, singing, and what would the fun module to wrap the 2 mixin is cute mixin to a fun module which should return an object. Okay, so let's start this out. So let fun mixin module. So we'll create this module right here, right? We will make it a function, right? And we will put this all in here. And then we will add another one here, right? And let us, okay, so hold on. We need to add these in here. We need to add this up. Do some cleanup here. There we go. So now we have the cute mixin right here, right? And it's going into this function. So we're not going to add this here. We're gonna put this here. So we're gonna make the is cute mixin an object property, right? So it's gonna, we can do this. We have the function. Instead, let's make this a arrow function, right? So the object dot is cute return true. Right here, we're gonna make this object. Let's get rid of the sing, right? We're going to add this here. So now these are both properties within an object. This fun module object. So we have an object here that's called fun module. It's equaling it to this right here. It's a function. So that way it takes the object of the cute mixin, right? Okay, so it's taking this and then accessing using this, or accessing using this. So we're gonna use this, and then use an arrow function. What is this? So it uses this cute mixin, takes that, sing, mixin. Okay, so why? Oh, because this is an argument itself, it looks like. Right. So we want this to immediately evoke. So we gotta add it to here. And add this, right? And this will immediately be ran. So this, basically we're wanting this to immediately be run. We want the object, we have this object. So this object is cute. We're giving it this function, right? Right. So we're gonna give it that as true, and this should have that. So this isn't gonna be here. So this is all within here. This is the first one, this is the second. This is the end of the object. This is the immediately invoke. But why is this? So so we have this, right? So we have an object here. That doesn't make sense though. I'm sure that alright, so what missing semicolon. So we're looking at this right here. So why would this? Why would that be that? We're making an object. Oh, because we're not returning one. We're okay. That's why. Because we're not returning this. There we go. Because we have to return this right here, because if this wasn't an object, then it wouldn't, you know. If this was an object, then you can't do this. It makes it as individual strings. But since we're making it, we're return, like when this is called, we're using a return, and it's either going to be this or it's going to be this. So it's going to take a parameter here. So name fun module, right? And wrap the to mixin is mixin should return an object. So we got that. So it looks like we're good. We did a reach. And now we can do... Oh, well, I guess we can make a whole object and do an example and all that kind of stuff. But, I mean, we did motion module, dot, glide, mix in, and then, you know, you choose which one you want. You know what, screw it. Let's do it. Let's do a, what object do we want to define? Or what constructor do we want to write? Let's do the bird, right? And then right.
Now why don't you confess?
We're not, oh, I could do this. So there we go. There we go. Bird. And then, well, we'd have to do a let, wouldn't we? Instead of writing a function, could we just do bird, and then just have this empty? Dang. I guess we would have function bird. Okay, right. There we go. So there's our thing right there. We can do a let canary equal bird new bird object, right? And now we do a, now we want to add is cute and a sing mix into it. So we would do a fun module, right? Dot is cute. Well, sing mix in, right? And when you're doing editors, I mean, like when you're using an editor, a lot of this stuff should like autofill for you. So don't feel like you need to know every single thing. So now we're adding the sing mix into canary, and then when we call the canary dot sing in an awesome tune. So now we've added the sing to it, and now we can also add a mix in. So fun module dot is cute mix in, right? Canary, right? We're adding these to it. Canary dot is cute. And the only way to see that, you'd have to do a console.log. There you go. But yeah, see, you just take whatever this is right here, and doing dot notation, you're getting to this, right? And then you are entering inside the object what it is. And now whatever, you know, you're getting this, you're adding the object into it, so now it's adding that to this, essentially it's adding it to this prototype, or to this object, specific object. So yeah. And now you can access it by using here and right here. So the object can use the is cute, and that's equal to this, or the sing and is equal to this. So there you go. And there you go. We've hit 100%. And it just took at 3 hours. But it makes sense because this area of using object-oriented programming is essential with any programming language you do. Like whether you use Java or you use Python or you're using JavaScript, object-oriented programming is highly essential, to make things a lot easier and to prevent things from repeating it, preventing itself, to be able to call, create actual objects of certain things and be able to call those things whenever you need it throughout your code. And it works well with databases, and it makes it easier for programmers to understand where everything is kind of coming from, and it gives these methods or whatnot to know, okay, where is this constructor coming from? Does it have this kind of property? And so on and so forth. So, it's very valuable information. So the next thing that we will be doing the next time we come through is functional programming. So it's a lot of basically, let's kind of look over it just briefly. Is another popular approach to software development. In functional programming, code is organized into smaller, basic functions that can be combined to build complex programs. So in this course, we'll learn about core concepts of functional programming, including pure functions, how to avoid mutations, and how to write cleaner code within methods like .map and .filter. So be prepared for that for the next one, that we next time we come together. And that'll only be 24 steps. Won't be as intense as object-oriented programming, but after that is when we have our real big challenges, where we have our intermediate algorithm scripting, which that'll probably could take 3-4 sessions maybe, depending on how hard it is. And then we have our algorithms and data structure projects. So once we figure out all of those projects and we get those completed, we finally get to claim our certifications. So, and mind you, all of these things that we do, we can take and save it, and then we can add these into like a portfolio, or that page that we've created, put them up on your GitHub, so on and so forth, so that way you can show what you've been doing. So yeah, thank you guys all for coming along, sticking with me through this. I know there was a lot of things that we had to go over, but I hope you guys were able to learn the importance of object-oriented programming, the different ways that you can do things, and yeah, it may be hard to understand now and do, but once you've been able to do it enough, and once you get into your first job, you'll have a lot of other programmers and senior programmers or whatnot that'll probably look over your code and stuff and help you improve if you forget something. But it's highly encouraged to look at the documentation, look at Stack Overflow, research, and then if you really are having a difficult time, then go to your coworker and say, hey, I've tried looking everywhere, but I'm trying to figure out this issue. Because I'm sure your coworkers are, extremely busy as well and trying to meet deadlines and stuff. So they want to make sure you took all these other routes to research before, you're really at a huge loss to minimize downtime. So, don't hesitate though. if anything becomes like extremely hard, you know, you always can reach out. But you know, a lot of, you know, groups too as well. If you go into like a lot of these programming groups, the biggest response, and I know a lot of people hate it, is did you look it up on Google, or did you look on Stack Overflow? Because most of the questions that you might ask could already be there, or it could already be, you know, if it's a simple question, you know, it could already be heavily answered through like a simple Google search. So, you know, some people could start to get irritated, and you know, because they know that you have the capability to go out and try to research some of these answers yourself. But in a learning environment like this and that sort of stuff, I mean, you know, I'm open for questions and that sort of stuff, and you know, I encourage it. But you know, I also will do the same thing where I'll refer to my previous videos, like say, hey, you know, we covered this heavily, and you know, in one of the previous videos that we did. Or you know, if it's like a basic thing, like hey, you should go watch, you know, early on, you know, these videos on my page. But yeah, if it's, you know, a quick answer or something like that, I have no real problem like saying, hey, you know, this is what we do. But if a question is being answered or asked like over and over and over again, then I'm gonna start being like, okay, you should definitely, you know, start going back, look at this stuff, because it seems that you highly didn't grasp that concept when we went over it. And maybe, you know, reviewing that material might be very beneficial. So yeah. Anyway, next time we come through, we'll do the functional programming. We'll probably bash our heads against the wall after that with intermediate algorithm scripting and, you know, making our projects. So just be ready. It's going to get a bit harder from here, but once we have that certificate, it's all worth it. So, alright. Thank you guys for sticking along. I appreciate it. We will come together next time. And, yeah. Have a good night.